plasma be applied in food technology to promote food safety, food quality, and preservation, meaning extension of shelf life. So we're going to look at that from a high level. There's a lot of detail that can go into this, but since this is just the introduction to it, I'm going to talk and point out the key points and the key considerations, and we can go further, separate email, separate dialogue, if you will, after this seminar. Okay. So what it is the most common term is non-thermal plasma. That's why I know I'm shifting terms on you, but that's what happens on these scientific papers. You'll see 10 different names for this, but it's typically referred to as non-thermal plasma or atmospheric cold plasma. So that's what I'm going to refer to it throughout the presentation, if you don't mind. And I'll describe it in general. The reason it's non-thermal or atmospheric is it's at room temperature. So we're not heating beyond the room temperature or normal temperatures that are expected. So that's a very important point to remember, is that we're at non-damaging temperatures. And that's going to come into play as you see some other slides when I get to them. But the key feature is it has reactive species, primarily hydrogen peroxide gas and reactive oxygen species. And these species only have a half-life of maybe a millisecond, microsecond, or nanosecond. It doesn't take long to break the DNA and RNA of a pathogen. And we'll cover that a little bit more, but that's why that is such a critical thing to remember, is that it's producing very controlled amounts of these highly reactive oxygen species with hydrogen peroxide gas. And the beautiful thing is this air treating air. There is no chemicals. There are no additives. There's no maintenance on it. It's simply plug it in and the reaction chamber creates the treatment, okay? The air does not have to pass through the device to be treated. It produces treatment and puts it in the space to react wherever the pathogen is located. Very important thing to remember. So the relevance in food science and food safety and food technologies is that hygiene is improved, the pathogens are under control, microbials under control, and we enhance health of all the workers as well as the food products that we're putting out and producing for society. So how it works is—
Pardon me,
yes.
Professor, pardon me, I don't know, but can you please just scroll down your slides, please?
Do what? I'm sorry.
The slide you are just, can you please just scroll down to the next slide, please? Because you're stuck at the first slide.
How about that? Did it change?
No, but
know.
maybe. Okay,
Oh,
can you, yes, click.
I'm clicking enough. I'm seeing it on my screen. That's what I mean. I've never used Google Meet, so I'm sorry. I don't know.
Yeah, no, that's okay, Professor. Maybe you can just click at the main slide.
Yep. So you see the first slide, which is application, right?
Yes.
I just click. I see the next slide, but you don't, correct? So let me see.
Yes, we can see it now. Introduction to non-thermal plasma.
Okay, I see what I have to do. I see. I got to do this right here. Now you see it?
Yes.
Okay.
Thank you.
That slide was what I just reviewed, so I'm sorry. But these are the key features of what I just mentioned, or here the bullet points for you to remember. But just remember, it's at a non-damaging temperature because it's room temperature. It's essentially at room temperature. The next slide is how does it work? I basically introduced it, but the mechanism is it's taking air and it's producing these ROS and RONs, which is reactive oxygen and reactive nitrogen species that disrupt the cell walls. That's a very important point. Most other non-thermal plasmas, and I'm talking about the one that's most effective here, the most other types of treatment, I should say, and they're called non-thermal plasma because they don't have accelerated high temperatures. They only, what they do is they call it agglomerate. They attach to the pathogen to make them bigger so they get caught in the filter. So they are not deactivating the pathogen. They're just simply attaching it, taking it for a ride through the air system till it gets to the filter. That's a very critical thing to remember. Secondly, because it's in the air and it's disrupting the cell walls, anywhere that air can envelope, meaning a table, a fork, a bottle, anywhere, is cleaning the surface as well, because this gas is surrounding that object. Okay. So that's a very important thing to remember. It is a gaseous, it fills the space, and it does not need to pass through the air conditioning system through the device like most other technologies. So it's happening at the location of the pathogen or the VOC or the contaminant. So what happens, since it's USDA organic and European organic certified, registered, it has no impact on human beings, animals, or plants because it is an organic product. It is simply air that's being converted into a plasma treatment. It does not create any stress on the food products itself, on the animals, that's like the cattle, the chickens. It reduces, actually improves the health of the animals, and it will affect toxins and pesticides that are used in some of the indoor farming applications. The other thing is, because it is organic and it's non-thermal and it's treating the pathogen, it's not damaging the structure of the food itself. That means discoloration is not going to happen. It means red meat's going to look like red meat. So it doesn't turn it different colors like some other treatments, especially high heat and high stress types of treatments. So basically what we're going to talk about is, why is it so important to understand non-thermal plasma and how we can use it to revolutionize food safety, food science, and food technologies. There's many benefits, and you already got me because I sound like a broken record. It is non-thermal. It is not high heat or high stress on the thing. So what we're going to do is look at what does it do for food safety? Well, it comes into play very, very important nowadays. Cross-contamination happens a lot in food processing, and we're always wiping down between runs, etc. Packaging can be affected by non-thermal plasma because it is a gas in the air that can get sucked into the packaging. Bottling operations can be affected because it will treat the inside of the bottle to preserve the liquid or the fill that you put in there. It's always searching out and destroying the bacteria, the fungi, the viruses, any kind of mold spores, etc. One of the biggest things we've learned and seen over 25 years is Listeria, E. coli, and Salmonella are the big ones, as well as Aspergillus, the biofilms that happen in food processing facilities very commonly. So this will deactivate those in a matter of minutes. And I'll give you an example in a second. But what happens is, let's go to produce and apples, tomatoes, bananas, etc. The surface of those fruits and vegetables is what makes them retain the freshness of the vegetable or fruit. So tomatoes put off a gas called ethylene gas. Ethylene gas ripens bananas. So if you're in a grocery store or a food store or a produce storage house and you're mixing the products, the off-gassing from one may cause the ripening and spoilage of another. With non-thermal plasma in place, it is affecting those gases to help increase the shelf life of those produces, because the gases that act as a ripening agent to other product is being mitigated, so to speak, so that it doesn't speed up the ripening process. Studies have shown shelf life increases 7 to 12 days for produce and fruits. How about pathogen control in poultry and seafood? Because again, it is a gas, let's think a little bit out of the box, if you will. This gaseous molecule can be pumped into water as well and treat the water lines, the water supply nipples, if you will, that goes to all the different animal stations. And it can also be used in seafood farming because it will help control the bacteria in I think it's called fish lice or something like that, that can affect the health of the fish in the ponds. So there's plenty of applications: air, surface, and water. Non-thermal plasma is becoming very fast the number one go-to treatment because of the impact or lack of impact of affecting the food itself and the impact of increasing the shelf life, letting you be able to increase export and import opportunities. So I gave you the example of salmonella and listeria, but this technology is so effective. There is many, many, many white papers and research projects on it. One of the things that always comes up in the research is further study needs to be done. It's so effective, and there's so many ways to apply this plasma treatment. The mechanism of delivery is what really matters. Okay, so we're going to be careful at what we look at, how it's delivered and created, because it does make a difference of how it's created and delivered. So for shelf life, I explained that to you in a nutshell a minute ago, but I want to reemphasize it. It's the microbial growth on the product that's being eliminated and mitigated. So that helps it ripen and spoilage. The ripening and spoilage take natural instead of speed up because of off-gassing from something else. It delays oxidations in oils and fatty foods, very example. It will help in the packaging if we inject, say you have a vacuum seal package. If we put non-thermal plasma in the airline for the vacuum seal, it sucks some of that treatment into the sealed bag and keeps that product 7 to 12 days longer, because now you have a clean treated product in the package. It does not affect the taste. It does not affect the appearance or the quality of that product that's in that packaging. Any comments or questions so far before I continue? Okay. So let me get to the next slide. So what we see in the studies over 25 years of this being in the market and being in this kind of application of food safety and food technologies is we see that the fruit texture is maintained in vegetables and fruits. This texture of the product is maintained. It doesn't become mushy or change colors or anything like that. Everything is the same. The freshness of the smell, the freshness of the taste, and the color is more vivid because it's not spoiling and while it's sitting on the shelf, if you will. So that's all because of how this affects the gases and the enzyme reactions that are happening on all these different types of fruits and vegetables. So it's very important that if you have something on display, if you think about going in the grocery store, you go to bananas, you'll see green ones, yellow ones, and brown ones starting to turn brown. It's because they've been at different stages of their ripening process, and if they've been in a back room mixed, they're ripening very fast. And you'll notice in the grocery store, you can have the bananas and stuff on one, I'm gonna say one shelf, and then right next to it or across the aisle or the tomatoes and stuff like that. So there's gases coming off of all these different products that are affecting each product. With non-thermal plasma or atmospheric cold plasma, it is eliminating those gases so those fruits and vegetables stay fresher looking, keep the color, and maintain their life much longer than normal. So I have an example here of where it's used in food processing and the types of applications. We see this, and there's ways to use this in the grain and seed treatments to control the mold and fungi that happen in your grain and your grain silos and stuff like that. We have different areas where we have the studies on almond factories and spices and seeds where it helps decontaminate them so they can grow and be very healthy and more productive plants. We have it where we just did another study to prove this on the peeling of eggs. We did a hard-boiled egg facility, ready-to-eat facility, and they said that their peel rate was increased dramatically and their damaged product decreased because the non-thermal plasma absorbs through the shell, and that little sticky membrane that sticks to the hard-boiled egg that causes you sometimes to chip away a little bit of the egg itself is loosened from it, so it just slides right out. So the egg is still perfect looking. So we've got a study that we just repeated it ourselves here in U.S. and Tennessee, and it was phenomenal. It's just amazing what's happening. In baked goods areas, all the flours, the doughs, any ingredient for food can be treated with this device because, again, it's filling the entire space. It's a gaseous. So if you're mixing a grain, it's being mixed in with the grains, killing the grain mites, etc. So there's a lot that happens because it is a gas. So sterilization and packaging. This is done quite frequently, mainly in bottling operations. A lot of people have the wet cleaning of bottles and those kinds of things. We're actually pumping in some of the non-thermal plasma through a air system where the bottle's inverted. You pump it in, it flips over, goes and gets filled, and that treatment is inside the bottle, keeping the product fresh and clean. We've been doing studies in a couple different types of bottling operations where the impact of yeast in the air is getting sucked into the bottle itself and affecting the product. So we're cleaning the air and cleaning the packaging itself. So the best solution is always the entire facility to keep the air, because air treats air. Air is the cause of contamination for the most part. Okay. So we are reducing the needs for chemicals in these operations. We're reducing the needs for chemicals in rinse downs and wipe downs. So this product is very beneficial in many ways economically, and because of the lack of needing to buy barrels of chemicals and refill chemicals and resident times, etc. So there's a lot of benefits for this. So why do people look to it for a sustainability initiatives even? And that's becoming a big deal because wastewater treatment's a very important thing in society. And we're looking at how do we preserve the water or keep the water pure as we can, whether we're using it for cleaning or not. So this actually reduces the amount of water and chemicals that are needed to rinse down and wash and treat spaces. It's very low energy. It's basically like a light bulb. The device that gets plugged in uses the equivalent at the most of a 60-watt light bulb. So it's depending on the size of the unit. There's like 8 different size units, and we can stack the units depending on how much volume of air we need to treat. And you have a very low energy footprint. In white papers, you'll say one of the drawbacks of non-thermal plasma is the energy consumption. That is why I say there's a difference in the way the mechanism works. The best non-thermal plasma out there is what they call modulated dielectric barrier discharge. You will read a lot of papers that say dielectric barrier discharge. What's the difference between modulated and just regular dielectric barrier discharge? The difference is modulated controls the amount of treatment. Every pulse is a certain amount of treatment. So it's a true pulse. With dielectric barrier discharge, it's a erratic sine wave. So you're getting different levels of treatment throughout. So you don't really know what you're maintaining in the space. With modulated, I can tell you it's producing 37 parts per million of this all the time. We know that it is specifically to that output. We can design it and engineer it to put out the level of treatment required for your operation based on your situation. So that's a very important point. So when you're looking at non-thermal plasmas, there are different types. The most effective, the most controlled one that you can know is happening continuously with much stability and constant output is modulated dielectric barrier discharge. So when we look at it, and again, I'm using the white papers to help make the point so you can see how this is very revolutionary that's being talked about. They talk about always the scalability to industrial levels. The reason they bring that up is because they are just dielectric or plasma jet, or they're not really room filling technologies. This is the modulated allows for room filling technology, so you can scale it very easily to whatever the cubic meters of air volume is, or the flow of water. We can engineer it to those metrics and set the treatment level at what's required. So that leads into the treatment uniformity. When we know what the challenge is in the facility, we can engineer to that challenge based on 25 years of experience and data, tell you, you will need this much treatment. Say, I'm making this up, 60% of the output of the machine. It will take us 12 days to clean up your existing bioload, and then you'll see the curve for degradation and mitigation of these pathogens and these contaminants of concern that you're trying to get rid of start dropping very quickly. The first week or two, it may take a little while to clean the existing load in the room. Okay. As far as regulatory approvals and public acceptance, one of the biggest things that we see in the market because of lack of education and lack of true understanding is the reactive oxygen species. Reactive oxygen species can be harmful to humans when it's above certain levels. Thus, another reason to have modulated. The modulated keeps it controlled well below anything that impacts human beings or animals or plants. Dielectric barrier discharge by itself, because of a sine wave, can produce more ROS than you want that could cause some health issues. So it's a very important point. So that's why they talk about regulatory approvals as something to consider. The technology is now in ASHRAE, getting reviewed for testing methodology to prove the safety and the effectiveness of it for you. There is a new standard coming out to address this. However, it's been used by USDA. It is the USDA organic, as I mentioned. It is the European Union's organic certified as well. It has the zero ozone emissions stamp from UL. It's got the halal certification. It contributes to TAIB exceptionally well. So there's a lot of pluses, but again, it's modulated dielectric barrier discharge that we want to look at. So how do we really use this as an innovative approach? It's when we look at the engineering of the space and work with yourselves and the customers, we understand, we take and try to learn the operation and find the gaps or weak points of your HACCP program. Where are the critical control points that we're after? Where's your GMP needed more? And I'll give you a good example. In the wine business in California, we found there's a gap in the bottling operation because the way it's being done in this particular facility, there's yeast being produced, which is getting sucked into the bottle, which is ruining the wine. So we just need to understand how to integrate it into your production line to make it the most effective. Next thing is, how do we look at it in the impact on making sure the foods grow better and stay healthier, and more productivity of the meat, more productivity of the vegetables, the fruits. Studies have shown that this device in a indoor agriculture environment helps germinate the seeds faster, helps the plant grow faster, and actually produce 30% more production of the plant, meaning the leaves, like on lettuce, would be bigger, roughly 30% more yield. And that's a lot to consider and a lot to know that this device and this technology can help in health and productivity of your facilities. And last was, I talked about aspergillus, the biofilm, very hard to control and get rid of. In the US, the Environmental Protection Agency has been banning certain chemicals that are being used currently to deal with aspergillus, because in a food processing facility, any of that chemical gets in any food, it has very dramatic human health impacts. So with this device, because it is organic, it can be on the food, it can be in you can breathe it in, you can do everything, it's totally safe. we're learning how to incorporate it and integrate it into the packaging operations and keep the films and biofilms under control in that processing area. So in a nutshell, high level, this will be roughly 15, 20 minutes here. I apologize, I went over my 15 minutes, but it's a very versatile, sustainable technology. The reason I say that is because it is an application engineered solution. It is not an off-the-shelf purchase. Hey, I think I need two, send me 2 units. We won't do that. The company I represent and work for and consult for, we will say, we want your metrics, we want your engineering drawings, we're going to engineer the system and tell you what will do the job. And then we'll have discussions of the budgets, how long you want to take, etc. Safety, not only of the personnel is improved, quality of food, shelf life of food, and the safety of the food products are enhanced. And I know today that food quality is becoming a really big deal because we see so many recalls lately happening across the world. One of the things that I've been talking to USDA about, they have a lot of research going on for the use of non-thermal plasma, and they're actually creating a plasma activated water technology lab to study the impact of using non-thermal plasma in water. There's been research projects on that. We have real live applications that we've done. We have test data showing how fast it impacts anything in the water. And I'll be glad to share that too. But this device and this technology with the proper way of producing the plasma is very versatile and very, very, very impactful. So with that, I'll ask if you have any comments or questions for me. I'll do the best to answer them. If not, you'll have this when she distributes it. You'll have my email here to reach out, and I'll be glad to share anything and any lab results and studies that I have that will help you in your market or in your area of interest. So thank you for your time, and if there's no questions, I truly appreciate the opportunity to present.